We've touched on these concepts a little bit before, but let's take some more time right now to look at the difference between linear and exponential growth. Considering the following situation, Alphonse and Becca both have 100 followers on social media. Over the next 12 months, Alphonse's number of followers will increase by 10, while Becca's number will increase by 10% each month. Who will have more followers after 12 months? Well, let's think about how many followers they're going to have for each month. So Alphonse is starting with 100. Well, next month he's going to have 10 more than that. And the next month he's going to have 10 more than that. And the next month he'll have 10 more than that. And so we'll see that that's increasing by a value of 10 every single month. Then let's take a look at Becca. Well, the first month, Becca's also going to have 100. And then she's going to have 10% more than that the next month. 10% of 100 is 110. And then the next month, she's going to have 10% of 110. So instead of adding 10, we're actually adding 11. And Becca's going to have 121 followers. And then that's going to continue. 10% of 120, we're looking at approximately 12. So we'd have approximately 133 followers. And so that's going to continue to increase in that rate. And we see that month 0, 1, 2, and 3, 0, 1, 2, and 3, for each month, Becca already has more followers than Alphonse does. Well, that's because her growth is based on a percentage of the previous, and the amount that it grows each month is getting larger. The amount that it grows each month increases. That's because of that percentage growth. So we refer to these as linear and exponential growth. Alphonse is a linear growth, while Becca is an exponential growth. So given any table of x and y, we can look at the change over time and identify whether it's linear or exponential. Change in y can be represented by repeatedly adding the same value over and over and over. We call this a common difference. Now the common difference is actually going to be the same as the slope. That will be the slope value. And so when we find that we have a common difference from term to term, that gives us our slope. And so if we know the common difference, which is the slope, and we know the initial value when our function equals x equals 0, then we have an equation in the form y equals mx plus b. And we can look and see that for this equation, we have a common difference of 2. Common difference can be found by calculating the difference between one value and the previous. And we keep getting the same amount every single time. So our common difference is 2, which means m equals 2. And then our starting value is given when x equals 0. If we're given it, then we can go ahead and write our equation. Y equals 2x plus 3. Now, if our initial value isn't given to us, we can always calculate it using our linear equation. For example, if I didn't know that y was 3 when x is 0, I could go ahead and take any other point and I could substitute it in along with my common difference in order to find our initial value, which gives us a value of 3, and then we can write our equation. On an exponential equation, we are looking for the change over time, which is represented by repeatedly multiplying by the same value over and over and over. Again, we call this a common ratio or a common factor. Our basic exponential function is represented by y equals a times b to the x power. So b represents our common factor, what's being multiplied over and over and over, while a is the initial value when x equals 0, just like with the linear equation. So instead of finding the common difference, we notice that, well, as I increase from one to the next, the increase is not the same. 3 plus 3 is 6, 6 plus 6 is 12, 12 plus 12 is 24. The increase is different. So there's no common difference. Instead, it's a common ratio. We take one value divided by the previous, the next value divided by the previous, and the next value divided by the previous. We can continue that pattern, and we see that we get the same ratio of 2. So our common ratio, our b value is 2, And then we can again look for our starting point, and we can identify and get our equation. Y equals a times 2 to the x power. When we're trying to determine based on a word problem whether or not something is linear or exponential, we're looking for phrases that indicate whether the growth is constant or not constant. So anything that represents a constant rate of change, changes by a fixed amount over time, or changes by a percent of the initial value. And this is important because the initial value is a constant. The initial value is never changing. Therefore, even though it's a percent, it's still the same amount of the change over time, which gives us linear. However, if we're changing by a percent of a current value, like with Becca's subscriptions, that's going to be exponential. Or if we're changing by a factor, such as doubling something, tripling something, or halving something, that will also be exponential. Let's take a look at these scenarios and identify what part tells us if it's exponential or linear. The population of a village decreases by 2.3% each year. Here, the current value is implied by that change. Each year, we look at how many residents there are and decrease by 2.3%. That's exponential. George has $200 for lodging while traveling. He pays $40 per day while staying at a hostel. He's paying the same amount every day. That's a constant rate of change, which is linear. A plant's height increases by 5 centimeters per day. Again, a constant rate, linear. For a savings account, 1.25% of the current value is added to the value each successive year. That is exponential. It's a percentage of the current value. So let's go ahead and write our own linear and exponential equations. Again, we want to find our common ratio or our common difference as well as the initial value and use those to calculate. So here we have to identify first, is it linear or exponential? Well, do we have a common difference or a common ratio? If I take values and subtract them, such as 8 minus 1, 15 minus 8, and 22 minus 15, I get the same value over and over and over, which is 7. And that's going to give me my common ratio, or I'm sorry, my common difference. Because each of those differences gives me the same value, I know that my common difference is 7, which is my slope. If I try to take 8 divided by 1 and see does that equal the same thing as 15 divided by 8, well, those are not the same fraction, so then my common ratio doesn't exist. That's how we know it's going to be linear. Then we just look for our starting value. So since m equals 7, b has to equal 1 because when x is 1, or x is 0, our output is 1. So we have a linear equation, y equals 7x plus 1. Here we look to see if we have a common difference. 10 minus 5, 20 minus 10, 40 minus 20. Those do not give me the same value. So I know I don't have a common difference. Let's look at the ratio. 10 divided by 5, does that equal 20 divided by 10? And does that equal 40 divided by 20? Well, each of these simplifies down to 2. So my common ratio, which is b, equals 2. The common. So then we look at our starting value, which is a. Our starting value when x equals 0 is 5, so a is 5. Y equals 5 times 2 to the x power. A bakery is giving away 600 cookies. The giveaway starts on a busy weekend and passerbys take free cookies at a constant rate. After 2 hours, the bakery has given away 50% of the cookies. Which of the following equations models the number of cookies remaining h hours after the giveaway starts? So here we have to look at, is it exponential or linear? Because they're giving away cookies at a constant rate, it has to be linear. So we can ignore any exponential functions. Then we have to find the starting value and the rate of change. Well, they started with 600, so our b value is 600. Then our rate of change. They gave away, in 2 hours, 50% of the cookies. So 50% of 600 in 2 hours. Well, 50% of 600 is 300 cookies given away in 2 hours. That gives us a unit rate of 150 cookies per hour. So we look and we see we have a unit rate of 150 cookies per hour and a starting value of 600. There's our solution.